Hey guys, Wendy Martin here. Take a second, look around. Do you have any idea what you're looking at? Do you have any idea what your blood type is? This would be the place that you could figure it out. Where I am right now is in the middle of a high school blood drive. If you look around, you can see that the blood center actually brings their equipment to us. Any student that is 16 years or older can donate blood. The process itself takes about maybe 45 minutes, but it is a vital process. Somebody needs blood every 2 seconds. A single car crash could require up to 100 pints of blood. So what these kids are doing right now is an incredible service. Okay, so if you guys take a look behind you, hopefully you can see that bag of blood that's being rocked back and forth. That is a pint of blood, and that's what we consider a unit. If we were to actually look closely at the blood that is in that bag, you would notice that the most numerous component is this guy right here, a red blood cell. You have trillions of them in your body. Now, inside of a red blood cell is an extremely important protein called hemoglobin. Hemoglobin is responsible for carrying the oxygen and the iron through your body. Now, an important thing to remember about proteins like hemoglobin is that their function is determined by their shape. And if you alter the shape of a protein, you alter its function. Now, how does a cell know what protein to make and how to make it correctly? Well, that's our good friend DNA. DNA is made up of segments called genes, and those genes are kind of a how-to for dummies, how to make a protein. And so if that gene is altered, protein production is altered. Chromosome number 11, on that chromosome in everybody's body, there is a gene that codes for the production of hemoglobin. And if something is wrong with that gene and it is altered or the sequence of the DNA is messed up, you're going to end up with hemoglobin that is misshapen. And if you get, and hopefully you guys know that you get this DNA from your parents, if you get a faulty DNA on chromosome number 11 from both parents, you can end up with a disease called sickle cell. And in sickle cell anemia, you're not going to have red blood cells that are shaped like this because the hemoglobin that is inside of them is not shaped the way it should be. And instead, you get these funny sickled cells. And what happens is they have a tendency to clump together. They don't go through the blood vessels easily. They cause clotting. They can cause severe throbbing, consistent pain. Because they are shaped funny, they don't live as long as they should, and so a person is always going to be low on iron, low on oxygen. That's where the anemic portion comes from. A lot of extreme fatigue and a lot of extreme weakness. About 90,000 Americans have this genetic disorder, sickle cell anemia. Now, one of the most obvious treatments for it would be a blood transfusion, sometimes as often as once a month. Where do we get the blood for these transfusions? Something like this. Look around. All of these people that are standing here are either donating or waiting to donate, and it's very likely that their blood could go into somebody who is suffering from sickle cell anemia and help alleviate their symptoms. Okay, another potential treatment for something like sickle cell anemia is gene therapy. And gene therapy is a relatively new type of treatment. It's been around since the 1990s, and it has been used to treat actually several genetic diseases that have no cure, not just sickle cell anemia, but hemophilia, which is another blood disease, cystic fibrosis, which affects the lungs, and even SCID, which is a immunodeficiency, affects the immune system. And what happens with gene therapy is we actually take a gene that we manipulate outside of the body to make it like we want it, and we put it into the patient. Now, how do you get a gene from here into the patient? Quite often they use a vehicle, and the most common vehicle they use is a virus. And I know when you hear the word virus, you think virus, that's going to give me a cold. Well, they can actually take viruses, take out the viral DNA, it's pretty cool, take out the viral DNA and insert the DNA that we want to put into the patient, and then they allow the virus to enter. And so what happens in the specific case of sickle cell anemia? Sickle cell is a little trickier because it deals with blood. We know that blood is made in your bones, and this is an actual bone, this is a tibia. Up here in this portion of the bone that is referred to as spongy bone, this is where you make your blood components. This is where you make red blood cells, white blood cells, and platelets. So if I want to treat a person with sickle cell, I'm going to have to treat their bone marrow. And so what they've done in the earliest trials is they have taken a sickle cell patient, they have taken out some stem cells, and they've put those aside. Then they will infuse that patient with a couple of rounds of chemotherapy, and you've probably heard of chemotherapy. It's one of the ways to treat cancer. But what the chemotherapy does is it wipes out the bone marrow in that patient. What they then do is they take these stem cells and they take a virus, which is the vehicle, and in the virus they have anti-sickling or healthy hemoglobin DNA from chromosome 11. They allow that virus to inject that healthy DNA into these stem cells. And then, much like you see right here, they will actually infuse those healthy stem cells back into the patient's body. And the hope is that those healthy cells, stem cells, get into the bone and start reproducing and make healthy red blood cells. Now, in the earliest trials, we have seen about a 50% success rate, and that's pretty good. A 50% success rate means that within a year, about 50% of the people are still making healthy red blood cells. Is gene therapy the cure-all and answer for these diseases? No, absolutely not. Not yet. It's still in some of the early stages of development, but there has been success and there's been a lot of interest. And so the hope is that we can take something that can be as intimidating as a virus and use it to cure disease, or at least alleviate symptoms. Science is pretty cool. The technology that is going to become available to us down the road is amazing to think about. This is Wendy Martin and Victory VR signing out.